one of the problems with virtual reality technology that we noticed is that whenever you're using a lot of the cheaper devices like the Gear VR and the Samsung or the Google Cardboard, is that it's very hard to control the device while you're using it. You can see here in this video that it's when you're trying to use it, either it's some kind of controller on the side of your head and it's very hard to use, especially in VR, or you're holding something that you can't always find when you're in a virtual reality environment. So our solution to this problem was to make an e-textile enabled glove that is always easy to find. And this is great because I always know where my fingers are when I'm in a virtual reality environment. I can press here, 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 here. It's a lot easier than trying to fumble and trying to find some kind of controller. So the first thing we did in order to make this glove is we deposited our silver nanowires on the fabric. This goes through a 5-step process. First, we use the mire rod and pipette deposition technique to get the nanowires onto a transfer paper. This is the same kind of transfer paper that they use to print t-shirts designs. Then we put this in the oven to heat it up and help form a better mesh amongst the nanowires. This transfer paper with nanowires is then deposited onto the fabric using a heat press technique, similar to putting an iron on regular transfer paper. Then the transfer paper is removed, leaving just nanowires on the fabric. The circuit that we used to do this has multiple components here. There's 4 fingers, one for each of these fingers, and then your thumb. The thumb forms the ground that when you touch it to one of the other fingers, it creates a capacitor. This capacitor is what we measured, and it allows us to give an input for each of the fingers. This graph here shows our different responses as you're using the graph. The flat line is the background noise, and then each bump is a tap. Here we have 3 different bumps for 3 different taps. We then have an SEM image here showing the nanowire mesh. This is what allows the material to be conductive on the fabric as the electrons run through the mesh. And then we have the final prototype here, which is displayed here. As we were going through this, we noticed there were some problems with it and some places that we want to take it next. So one thing is that we noticed every time you bend the glove, it can cause problems in the mesh and degrade it slightly, eventually causing it to break. So we want to work to optimize our nanowires in order to make the mesh more sturdy and to test to see just exactly how much it can withstand. We'd also want to test it on a variety of fabrics to see can it work on anything other than just the cotton, and allowing us to have a wider variety of applications. We'd also want to optimize the transparency versus the conductivity of the gloves. The difference between this glove here and this glove here demonstrates that. The second glove is our more final prototype, which has lighter electrodes on it. The ideal product would eventually have no visible nanowires and would just look like a completely regular glove. Here you can see a demonstration of it as we play the game 2048 using the 4 different buttons. Here's the silver nanowire glove. If you press this button, it goes left. This button, it goes right. This button, it goes down.